We'd like to demonstrate the Stanley Myers Dave Lawton pulse width modulator. Now this pulse width modulator is actually divided into two sections. Section A, which is located on the left side and includes the three controls, is your primary section. Your primary section, when you switch it on, is the main section of the unit, and it provides the pulse train going to your hydrogen generator. Now the B section, located on the right side, also has three controls. The three controls on the right side control the duration and cutoff time that is superimposed upon your main pulse train, so it cuts the unit off for preset durations of time. So we'll start by demonstrating the unit. Now the top control, turn the unit on, is the bandwidth control. The bandwidth control has three settings. Each setting on the bandwidth control will let you tune through a predetermined frequency range. You tune through the range by turning the frequency control. Now the mark space control that's incorporated with it also affects the frequency. And we have the B side. Now the B section of the unit will superimpose a pulse or a cutoff time upon the main pulse train. We'll start by switching it on. We're set on the low speed, so you'll see the light start to flash. Now the status light will enable you to monitor what's going on at the lower frequencies. If you look at the status light is switching off and on. This is superimposed upon the main pulse train. You can also see it over here on the amp meter. Each time the light goes out, the amp meter drops to 0 because the cutoff time has shut the unit down. When the light switches on, the unit is back in operation. You can control the speed and everything and the mark space with the section B side. The mark space control controls the width or the duration of the cutoff time. Watch when I vary the control. The light will stay on for a shorter duration of time, and the amp meter will stay on for a shorter duration of time. If you turn the control counterclockwise, the light will stay on to flash faster. And you can see the reaction on the amp meter, because the amp meter does not have time to drop all the way to 0. The switching is cutting the unit off and on at a faster rate. You can continue to increase it up to the maximum of the bandwidth that is set by the control on the top. Now we're going to move it up to the second bandwidth. You see the meter fluctuating faster, and you see the light fluctuating faster. We can tune through that frequency also and have full control over the cell and the time that it cuts off and on by turning the mark space or the duration control setting, which you're not able to actually visually see when it comes to the light unless you roll it back a little bit. You can turn the setting back a little and you can see the flicker on it. Okay, that's the demonstration for the Stanley Myers Dave Lawton pulse width modulator. Other units. This pulse width generator has an electronic circuit incorporated into the unit and has the capability of monitoring the cell temperature with an external temperature sensor mounted on the cell. When the cell reaches a preset temperature, which you have set with the temperature control located on the front panel in the center, a red light indicator will come on, and other features will also be automatically activated. This PWM with automatic temperature control will help you to gain full control over your cell and prevent overheating. I will briefly go over some of the controls. The power light indicator which is located in the upper left hand corner, and the first control is used to set the pulse width. It has an off-on switch incorporated with it. This control allows you to vary the amperage going to your hydrogen cell. This is adjustable from 0 to 100%. The next control is the variable temperature control. This variable temperature control is used to set the temperature at which you want to automatically activate the other preset controls. This includes the red temperature light, which is located above it. Right now it's green because it's in the normal operating mode. It includes the variable cutback control, and it also includes a 12-volt voltage supply which comes out of the back of the unit. When the temperature light is activated, you will have the option of having the PWM automatically cut back the hydrogen production to prevent overheating. I'll briefly demonstrate this by rolling the temperature switch back. If you watch the amp meter, you can vary the cutback. Okay, now we'll roll it forward back to the normal operating mode. And we'll next look at the status light. The status light is located above the cutback switch. When hydrogen production first begins, it will light dimly. Continue to increase the hydrogen production and the light will continue to get brighter. The mode light, located in the upper right hand corner, is also used to monitor and assist in the PWM hydrogen production. A 12-volt output is located on the back of the unit, which you're not able to see, and it can handle up to 8 amps. When the temperature indicator light comes on, a 12-volt DC is supplied to the terminals on the back of the unit. This can turn on a pump which can circulate the water through your hydrogen cell until it cools down. We currently have it connected to this fan so that we know when it is activated. When the unit cools down, the PWM will return to normal operation. The indicator light, located above the temperature light, will turn green. 12 volts, which is supplied to the back of the unit, will also automatically be switched off, and the hydrogen production will be restored to normal. Now let's do an act counterclockwise back until the temperature light comes on. Turn the cutback switch where you would like for it to cut back to when the temperature is activated. We will set it back on about 8 amps. Okay, now turn the temperature switch forward until the green light comes on, and we'll let the unit run until the temperature is activated. When the temperature is activated, the red light will come on, the amps will be cut back to approximately 10 amps where we set it, and the fan will activate because the 12 volts DC on the back of the unit will be applied. So now we'll wait for our cell to heat up. Okay, the temperature light is activated. It is turned red. The amperage is cut back to about 8 amps where we set it, and the fan is activated, which means the 12 volts applied to the back of the unit is turned on. When the unit cools down, the unit will go back into the normal operating mode. The temperature light will turn green, the amperage will return What we're working on today is the high voltage intensifier circuit for the Stanley Myers unit. We have our Stanley Myers unit here, we have our high voltage intensifier circuit here, and we have our spark gap so that you can monitor and you can see what's going on in the demonstration. Now we'll start by turning the PWM on. The first control on the PWM sets the pulse width. So as you turn the control clockwise, you'll notice that the spark will get stronger and stronger. Now I need to tell you that this spark is so loud it hurts my ears, and I don't know if you're going to be able to hear me very good over the spark. So I'll go ahead and tell you in advance, the first two controls set the main pulse width that come from the PWM and power the high voltage intensifier circuit. Now the next two controls are only active when you turn the switch on, but the first control will set the pulse width and the second one will set the frequency. So we'll start by turning the PWM on, and we'll start by rotating the dial clockwise, and you can notice the effects on the spark gap. Oh, I got a bad. Switch interrupts the main pulse control by switching it off and on. You can see the difference in the spark gap. Now the next control is the interrupt pulse width control. As you turn the pulse width control clockwise, it narrows the pulse width, and you'll notice the difference in the spark. Hear the spark narrow, and then turn it back. The second one sets the frequency. By turning it clockwise, you increase the frequency, and as we increase the frequency, we'll do the pulse width again. Narrow the pulse width. And that's all for the demonstration. We hope you've enjoyed it, and we hope you'll check back later for more information and further advances on the Stanley Myers high voltage intensifier circuit.